Hello friends, in this chapter today we will discuss about the concept description, characterization and comparison that we have studied in the last chapter. Data mining can be classified into two categories. One is descriptive data mining and other is predictive data mining. The descriptive describe the data set in a concise and summarized manner and present the interesting journal properties of data. And the predictive construct a set of models by performing certain analysis on the available set of data and attempt to predict the behavior of new data set. It means that is a prediction what will be the behavior of new data set. What is concept description? A concept usually refers to a collection of data such as frequent buyers, graduate students, and so on. Any of the topic can be described in the form of concept. Concept description generate descriptions for characterization and comparison of data. In the characterization, provide a concise and summarization of given collection of data, while class comparison provide the descriptions comparing two or more collection of data. Since concept description involve both characterization and comparison. Difference between concept description in online transaction processing and online analytical processing. Data warehouse and OLAP tools are based on multi-dimensional data model, which view data in the form of data cube, consisting of attribute and measures. Aggregate function we use for selecting the data or grouping the data. However, the data type of the dimensions and measures are restricted. Many current OLAP systems confine the dimensions to non-numeric data. Similarly, measures are count, sum, average. In current OLAP system, apply only to numeric data. These functions can apply only for the numeric data. We can count the number of items, we can sum the values, we can get the average. These are useful into the OLAP system. User control versus automation means there is a human intervention and versus automation of the system. Online analytical processing in data warehouse is a purely user control process. It means it is a misconception about the data mining system. The system do automatically each and everything. The selection of dimension and the application of OLAP operations such as drill down operation, roll up operation, dicing and slicing are directed and controlled by the user. Although the control in most OLAP system is quite user friendly, so there is no problem to use these type of tools. User do require a good understanding of the role of each dimension. If you have a background knowledge of the database, background knowledge of the data warehouse, you have go through with the concept, you know about the things you want to get, then there will be no problem. Furthermore, in order to find a satisfactory description of data mining or data, user may need to specify a long sequence of OLAP operations. These are available into the OLAP systems. Data generalization and summarization, that is based on the characterization. The data relation, the item relation in a sales database may contain attribute describing low-level item information such as item ID, name, brand, category, supplier, place where it is made, and price. It is useful to summarize a large set of data and present it at a higher conceptual level. If you want to do the summarization, a large set of data item relating to season sales provide a journal description of such data. What will be the winter sale, what will be the summer sale, which can be very helpful for sale and marketing managers. through they will compare this year's sale to the last year's sale, or this year's sale will use to compare with the coming year of sale. Data generalization is a process which abstracts a large set of task-driven data in a database from a relatively low conceptual level to higher conceptual level. For this, we use two methods. One is data cube approach and other is attribute oriented approach. Data cube means we have select some portion of the data, and in attribute we are selecting the data on the basis of the attribute. Data cube approach can be considered as data warehouse based, pre-computation oriented, materialized view approach. It performs offline aggregation before on OLAP or data mining query is submitted for processing. And the attribute oriented approach, at least in its initial proposal, is a relational database query oriented, generalized based, online data analytical techniques. If you want to generalize the data, if you want to make the characterization, attribute removal is an important aspect. For the attribute removal is based on the following rules. We have some certain rules to remove some unused or not relevant attribute. If there is a large set of distinct value for an attribute of the initial working relation, there is no generalization operation on the attribute. There is no concept hierarchy defined for the attribute. It means its higher level concepts are expressed in terms of other attribute, then the attribute should be removed from the working relation. If it is not used, then it should be removed from the working relation. Attribute generalization is based on the following rules. If there is a large set of distinct value for an attribute in the initial working relation, and there exists a set of generalization operators on the attribute, then a generalization operator should be selected and applied to the attribute. Both rules, either the attribute removal or the attribute generalization, claim that if there is a large set of distinct value of an attribute, further generalization should be applied. If there are large variety of data, further generalization should be applied. Now the question arises, how large is a large set of distinct value of an attribute considered to be? Is there any limitation? Is there any number of attribute? Is there on the basis of generalization? This question come and solve with the two common approaches to control the generalization process. The first technique called attribute generalization threshold control. Threshold means there is some limitation. Either set one generalization threshold for all the attribute or set one threshold for each attribute in a column. If the number of distinct value in an attribute is greater than the attribute threshold, further attribute removal or generalization attribute should be performed until you will get the minimum threshold value. The second technique is called generalization relation threshold. It is based on the dependency of the attributes. Set a threshold for generalization relation. If the number of distinct tuple in the generalization relation is greater than the threshold, further generalization should be performed. Otherwise, no further generalization should be performed. Such a threshold may also be preset in the data mining system, usually within the range of 10 to 30. Thank you. This is all about characterization and discrimination.